When taking the TA side, there will be some problems that require you to factor certain trinomials. Today that's what we'll be covering. So the most standard form of a trinomial is ax squared plus bx plus c, where a, b, c are coefficients. So first thing we do is, first we're looking at leading coefficients of 1, as in when our a value, our leading term, is equal to 1. So we want to factor into a form that looks like x plus m times x plus n, and if we were to FOIL, which stands for first, outer, inner, last, we would get x squared plus mx plus nx plus mn. And then what we do is we will group up our m plus n, which would be considered our middle term that represents a sum, and our last term, mn, would be our product. Now what we do is, in order to find m and n, we look for two numbers that have a sum forming the middle term and has a product forming the last term. So let's look at some examples of these. So we have x squared plus ax plus 12. So the first thing we do is we want to look at our last term, 12. So we want to think about what are products of 12. So we think of all possible factors of 12. So we know it's 1, 12, 2, 6, and 3, 4. So when we're factoring, again, it would factor into two binomials. So we have two sets of parentheses. We know the first term, because the leading coefficient is 1, is always going to be x and x, because x times x gives us x squared. Now, what goes here is the factors of 12 that multiply to get you 12, but add up to get you 8. So we go back here to our left-hand side of our factors of 12. We'll look at which combination will give us add up to get us 8. The only possible one would have to be the 2 and the 6. So the factors here, we can put a 2 here and a 6 here. So it can be interchangeable in this case, because since everything up here on our original trinomial is positive, then that means that our two factors are also positive. Now, you are always welcome to check if you are not sure that you factored correctly. So let's rewrite our binomials. Now, let's do the FOIL method, right? So let's draw arrows to show what the FOIL method is. First, outside, inside, and last. So our first term, x times x, gives us x squared. Our outside, x times 6, is 6x. Inside, 2 times x is 2x. And finally, our 2 times 6, which is our last, gives us 12. So now we combine like terms, which are our two middle terms. That gives us x squared plus 8x plus 12. And again, if you notice, this goes back to our original. So what that tells us is that this x plus 2, x plus 6 is the factored form of x squared plus 8x plus 12. Okay, so let's look at another example. So just like before, we want to look at our last term, which is our c term, which is 18. So we want to write on our side what are factors of 18. We know factors of 18. So let me make this a little bit nicer. Factors of 18 gives us 1, 18, 2, 9, 3, and 6. Now, this time our middle term is a negative 9. So we have a negative in front of it. So when we're factoring our trinomial to two binomials, again, we know the leading terms are going to be x and x, because that gives us x squared. But what goes here at the end here is now it's considered a negative, right? So that means we have to think of two numbers that multiply gives us a positive 18, but add up to get you a negative 9. So when we're doing this, we have to consider what are factors, or what two numbers multiply give us positive numbers. We know for sure it's a positive times a positive that gives us positive. But or we have a negative times negative that also gives us positive. So out of these two choices, we have to consider which of them would add up to get you a negative. The only one would be negative plus a negative will always give you a negative. So that's the one we have to consider when we're doing that. So when we're looking at these, we also have to consider negative factors. So negative 1 times negative 18, negative 2 times negative 9, or negative 3 times negative 6. So which of these would yield a combination to give us negative 9? The only one would be negative 3 times negative 6, because negative 3 times negative 6 gives us positive 18, and then negative 3 plus negative 6 gives us negative 9. So we have negative 3 and negative 6. And again, because they're both negative, you can interchange them if you wanted to. So you can actually write this, if you wanted to, as x minus 6 and x minus 3. So it's all up to preference. Sometimes on the TSI, they might give you two, since it's multiple choice, it might look like the first one, or it might look like the latter. So just be careful, look at where your signs are. Okay. All right. So this one, we have x squared minus 36. So first thing you think about is this a trinomial? It doesn't look like a trinomial because for it to be a trinomial, it needs to have 3 terms. In this case, we only have 2 terms, correct? But what we can do is we can rewrite this as x squared plus 0x minus 36. Why do we do that? So in order to see that, hey, this is a trinomial, and we know that 0 times anything makes it 0. So this equation, this term is equivalent to the original x squared minus 36. So we go just like we did before. We think of factors of negative 36. So 36, we know 1, 36, 2, 18, 3 and 12, 4 and 9, and 6 and 6. But this time we think about what two numbers that multiply gives us a negative 36, but add up to get you a 0. So in order to multiply to get a negative number, the only option would have to be a positive times a negative, right? Or vice versa. Either or would be fine. But they have to add up to get you 0. So in order for two numbers to add up to get you 0, is they have to be opposite signs, like we said before, but they also have to be the same number. So the only criteria that fits that would be 6. So 6 and 6. So we would have a positive 6 and negative 6. So let's check that real quick. So when we were checking, let's write x plus 6 times x minus 6. We check by foiling. So first, outside, inside, and last. So x times x gives us x squared. X times negative 6 is negative 6x. 6 times x is positive 6x. And 6 times negative 6 is negative 36. So we notice our two middle terms cancel. We're left with x squared minus 36. So what this is a special case. This is what's called a difference of squares. So difference of squares, what that is when you have a polynomial where you have a squared minus b squared. The difference is the subtraction, and squares is raising to a power of 2. So in our case, we have x squared, which is x raised to the power of 2, and we have a 36, which is 6 raised to the power of 2. This can always be factored into a plus b and a minus b. So when you're encountering a question like this, and you see it's in the difference of squares form, you can automatically factor it into a plus b, a minus b. Now, There's another case when the leading coefficient is greater than 1. So the standard form again goes as ax squared plus bx plus c, but then the integer is greater than 1. So there's a specific method to do this one. It's called the AC method. So the AC method, what we do first is we multiply the leading coefficient a and the constant c. Then we find the factors of the product AC that add up to the middle coefficient b, and then substitute with these two factors m and n. That gives us, so bx becomes mx plus nx. Then we use grouping to combine mx with ax squared and nx with c, and then finally we simplify. Let's try an example with the AC method. We have 3x squared plus 8x plus 4. First thing we want to do is we want to identify what's our a and what is our c. So a is the leading term 3, while c is our constant 4. So using the AC method, what we do first is we multiply a times c, which is 3 times 4, which gives us 12. Now what we do is we find factors of 12. So we know 1, 12, 2, 6, 3, and 4. 3 and 4. Okay, now our factors of 12 need to add up to get our middle term, which is 8x. So the only combination that works would be 2 and 6. So now what we do is we rewrite our trinomial as 3x squared, but instead of writing 8x, we replace it with 2x plus 6x plus 4. So we haven't changed the nature of our trinomial really. All we did was we replaced 8x with 2x plus 6x. Now, next step is we group. We group up our first two terms and our second two terms. And now we find the greatest common factor between each set of parentheses. So the first set of parentheses, we have 3x squared plus 2x. They don't have any coefficients in common because 3 and 2, there's nothing common between 3 and 2. So move on to x. So we see that there's an x squared for the first one and an x for the second one. That means that the greatest common factor would be 1x. So when we pull 1x out, we're factoring out x. So we should be left with 3x plus 2. Now we look at our second set of parentheses, 6x plus 4. So there is no x in common between both, so we can't pull an x out. But what we can pull out is a positive 2 between both. And again, we'll be left with 3x plus 2. Now, we now have two sets like this. So when we're thinking about the thing that's in common between both of them, would be a 3x plus 2. And our remaining, we group up. So our remaining are x and 2. So that would be our factored form of this trinomial using the AC method. Let's try another example using the AC method. So we have 2x squared minus 7x minus 30. First thing we need to do, again, is identify what's our a and what is our c. Our a is 2, while our c is a negative 30. So we want to consider that negative 30 because that will play in a little bit later. So using the AC method, we take our a and our c and we multiply them together. So 2 times a negative 30 gives us a negative 60. So now we find factors of negative 60, or 60 itself. 1, 60, 2, 30, 3, 20, 5, 12, and 6 and 10. So let's stop there for now. We have to consider those two numbers that multiply give us negative 60, but add up to give us our middle term, which is negative 7. So the only one of these that's possible would be 5 and 12. Because it's a negative 30 though, or negative 60 though, we know in order to multiply it needs to be one positive, one negative to give us a negative result. But they need to add up to get us a negative 7. only way for that to happen is if we have a positive 5 times a negative 12. Because 5 times negative 12 gives us negative 60, while 5 minus 12 gives us that negative 7, which is our middle term. So now what we do is we rewrite our trinomial as 2x squared, replace that negative 7x with a positive 5x and a negative 12x, and end it with the last one, which is 30, negative 30. Again, we group up our first two terms and our second two terms. Find common factors. First one, again, we can only factor out an x. So factor an x out, we should be left with 2x plus 5. But the second set of parentheses, negative 12x minus 30, we can actually factor out. And whenever you have a negative here on that first one, negative 12, you always want to factor a negative out. So what we can factor out is a negative 3. Or we can do more than negative 3 actually, right? Because the greatest common factor. What we can do is a negative 6. Factor on negative 6. Again, we'll be left with 2x plus 5. And again, our common terms are the 2x plus 5. And then our leftovers are x and negative 6. So we can now write this as our two like terms, two common factors, which is 2x plus 5, and our leftovers, which is x minus 6. So that should be the factor form of 2x squared minus 7x minus 30. And again, if you want, you're always welcome to check. So we're checking, again, using the foiling method. First, outside, inside, and last. So we have 2x times x gives us 2x squared, 2x times negative 6, negative 12x, 5 times x is a positive 5x, and 5 times negative 6 is a negative 30. Combine like terms, we get a negative 7x minus 30, which checks out. So that means that this 2x plus 5 times x minus 6 is our factor form.